Good morning, chemistry students. My name is Mr. Adam. This is chemistry. Today is the 15th of May. It is a Friday. Happy Friday, everybody. And it is a day 2 in our rotation. So happy Friday, everybody. We made it through another week. We only have a couple weeks of school left, which is really exciting. It's a beautiful day on Friday. The sun is coming out. The weather's warming up a little bit. Everything's good right now. And today we have a really good lesson going on for you. So today we're talking more about this concept of polarity. So polar, whether or not something has a charge or not. And we're talking about why polarity might occur, why a molecule might be polar, why it might have these partial positive and partial negative charges, why, like water, it might be attracted to the negative charges, the electricity on a balloon. So we're going to talk about polarity, and why this is exciting is not because, polarity is awesome, even though it's kind of cool, but because we're actually going to go through this lesson by reading a comic. So your textbook has this awesome comic starting on page 221 called The Bare Essentials of Polarity. It's very funny. It's about a polar bear and a penguin, and it shows why atoms combined to form molecules might be polar or non-polar, why they might have polarity, demonstrate this polarity, or why they might not. So go ahead and open up to that comic on page 221, or go ahead and open up to it in the Google Classroom and check it out. I'm going to be holding up my textbook and showing you this comic as we go through it to kind of talk about the different pages and talk about what we're talking about. Okay, so this is the bare essentials of polarity. Okay, so in the bare essentials of polarity, we're talking about polarity. And remember that polarity just means whether or not a molecule is charged. If it's charged, like the water was that we saw the other day, it can be attracted to things like a static electric balloon or a charge from Van de Graaff generator, or any other sort of charged particle, right? So whether or not it's charged or not charged is what we're talking about when we're talking about polarity, polar molecules. Now, in order to understand polarity, in order to understand why polarity happens, we need to understand this concept, this thing that we call electronegativity. Now, we haven't talked about electronegativity since, I guess, about Unit 1, which was all the way back in November and December. Crazy to think about, but we haven't talked about electronegativity since then. So we have to think about what that word means, right? Electronegativity. Well, it sounds like something to do with electricity, but really it has something to do with electrons, right? So all that electronegativity is how badly an atom wants an electron. You can have atoms that really want electrons that are very electronegative, or atoms that don't really want electrons that are not very electronegative, right? An atom that's really close to having 8 valence electrons, remember every atom wants 8 or 0. An atom that is really close to having 8 valence electrons really just wants to gain a few more, so it's going to be really electronegative. And atoms that are really close to 0 just want to lose a couple, right? Shed a couple electrons and get rid of them. And so they are going to want to lose electrons. Except now, when we're talking about covalent bonds, we're talking about molecules, most of the elements that we're talking about are nonmetals. And they're sharing electrons. So they all want electrons at least a little bit if they're sharing them, but some are going to want more electrons more than others want them, okay? And when we're thinking about electronegativity, you can think about it being how strong an atom is. And that's why in our comic, today we're representing atoms like chlorine, which are really electronegative, with a polar bear. This is a big, strong polar bear, right? It really wants electrons. Today I will play the role of the polar bear. And on the other hand, atoms like hydrogen are represented by this tiny, weak, insignificant penguin, right? So this tiny, weak, insignificant penguin will be represented today by the lovely Kristen. It's coming in now. This is the tiny, weak, insignificant penguin. She's not a tiny, weak, insignificant penguin in real life. She is very significant to me, and she hates penguins. So
that's not true.
The team, not the animal.
There you go.
So this is Kristen, the tiny, weak, insignificant penguin. She's representing an atom that doesn't really want electrons as much. It's weaker. It's going to give up the electrons much more easily, right? So anytime you have a bond, 2 different atoms are going to want electrons different amounts. And in this case, the polar bear is much stronger. So you can see it's taking those ice cream cones, those ice cream scoops, away from the penguin. They're still sharing, but because the polar bear is stronger, it's pulling those electrons towards it more, right? And whenever it pulls electrons towards it more, it becomes more negative. And the one that loses the electrons becomes more positive. Why is that? electrons. What kind of charge are electrons? Protons are positive, neutrons are neutral, and electrons are negative. So whichever atom has the electrons closer to it becomes more negative. So let's check this out real quick. Let's check out a demonstration of polarity. So big strong polar bear over here, tiny weak insignificant penguin here, but we both need electrons, right? We want to share electrons to both gain them, and so we're forming a bond right now, connected by two pieces of string, and these electrons, or just one electron in this case, are in the middle, and we're sharing them, but because I'm bigger and stronger and want electrons even more, I'm going to pull the electrons towards my side. So if I have the electrons, this balloon being the electrons, what am I? Am I partially positive or partially negative? Kristen?
I'm positive.
Okay, Kristen's partially positive, I would be partially negative, right? Because I have the electrons over on my side. The smaller, weaker atom that doesn't want electrons as much, still sharing electrons, still forming a bond, but the electrons aren't over towards her. So this is a polar bond because one of us has the electrons more than the other, right? All right, so we'll bring Kristen back in a second. So that's a polar bond, is when there's unequal sharing, when one atom is pulling the electrons more even though they're still sharing them. Now, if you look at the bottom comic strip here, you'll see our polar periodic table here, right? It's very important on our periodic table to note where the big strong atoms are, the more electronegative elements are, and where the weaker insignificant penguin elements are, right? So the big strong elements are up towards that top right corner. Things like chlorine and fluorine and oxygen are all very electronegative elements. They really want electrons, so they'll pull them towards them. Your weaker insignificant penguin elements over here are things like hydrogen, the alkali metals, right? They all don't really want electrons that much, and so they'll give them away pretty freely. Because of that, when you bond those two kinds of elements, you start to see these polar bonds, right? The only exception, this is an important one to note, is on the far right side of this polar periodic table, you see a keep out sign. Why is that? What's on the far right side of our actual periodic table? Well, if you look at our actual periodic table, you'll remember on the far right side is the noble gases, right? And the noble gases, do they want electrons at all? No, they are perfect and noble, and they don't need electrons from those peasants. They are perfectly fine by themselves. So they don't want electrons, and so they're not going to pull electrons to themselves very easily. They're not very electronegative on the noble gas side. Okay, so let's flip to the second page of the comic. Okay, so when you're talking about whether a bond will be polar or nonpolar, you have to be comparing the strength of the atoms, right? So again, if you have a polar bear and a penguin pairing up, polar bear is obviously going to be stronger, going to pull the electrons towards it more. And the penguin won't really get any electrons. It'll have the electrons taken away from it. That makes the polar bear, again, negative with all the electrons, and the penguin positive. Now let's imagine for a second that Kristen here is not actually an insignificant weak penguin, but actually a big strong polar bear, just like me, right? Thank you, Kristen. So big strong polar bear, just like me, right? So what if we have two polar bear atoms, two strong atoms bonded together? What's going to happen to this bond? Still a bond, electrons still shared in the middle, but pull like a minute, Kristen.
I'm scared we're going to break it.
Oh, it is close to breaking indeed. So if we have equal strength, right, if we're both pulling really hard on this electron, but not actually pulling too hard, then where is the electron, right? It's shared equally in the middle. Am I partially positive or negative, Kristen?
No.
No. Are you partially positive or negative?
No.
No, because we're sharing equally. So this is a nonpolar bond where we don't have any charges on us because we're sharing equally, right? Thank you, Kristen, for not breaking the balloon. All right. So the only time when you have a polar bond is when there is an unequal proportion of strength, right? When one atom is way stronger than the other and the other is way weaker, okay? So when we break down polarity, we're actually going to have three different kinds of bonds that we talk about, okay? So there are three different kinds of bonds that can form. The first one is called nonpolar covalent, okay? A nonpolar covalent bond occurs when everything is the same, right? Everything is equally strong. So you can have two strong atoms, like two oxygens bonded together, or two weak atoms, like hydrogens bonded together. And when they bond together, they form a nonpolar covalent bond because they're sharing equally. Neither is stronger than the other, so they're sharing them equally. On the other hand, you can have a polar covalent bond, and a polar covalent bond obviously happens when you have a polar bond, right? When two things are unequal. You have a polar bear and a penguin, and the polar bear is stronger, takes the electrons towards it more, and so, even though they're still sharing, the polar bear has all the electrons on its side, like you can see here. The last kind of bond we learned about all the way back in Unit 1, a long time ago, and this is when one atom is significantly stronger than the other. In fact, the weaker atom doesn't really want electrons at all, and it'll freely give them away. So one of the atoms, in this case the chlorine, will take the electrons entirely, right? And it'll take all the electrons, the whole ice cream cone, and the sodium in this case will give all its electrons away. Even though the penguin is saying, come back, and it looks sad, in reality, atoms that are really weakly electronegative, like metals, will actually give those electrons away intentionally, get rid of them on purpose. And so when you have that happen, you have an ionic bond, right? An ionic bond when one atom gives them all away and the other atom takes all of them. All right, the last thing to understand from this comic, and this can get a little bit confusing, is called a dipole, right? So at the top of this comic, it talks about a dipole being this thing that can mean 3 different things. Now, I don't want you to worry too much if this takes you some time to understand all the ways that you can use it. But we'll break it down a bit here, okay? The first thing a dipole can show is whether or not a bond between 2 atoms is polar, okay? So dipole definition number 1 is for a bond. What this is saying is, look at the bond that you have. Is it polar or nonpolar? If you have 2 nitrogens, is one any stronger than the other? No, they have equal strength. And so this bond would not be polar, and we would say it was not a dipole, right? This bond has no dipole. On the other hand, if you have H and Cl, H is a weak atom, Cl, bold here, is a strong atom. So where are the electrons going to go? All towards the strong chlorine. This makes this partially negative and this partially positive, and so we write for this a dipole. This dipole is an arrow. It shows which direction the electrons are going. So it points towards where the electrons go, and that's the negative side. And on the end you have this tail, which looks kind of like a positive sign, and this is the positive side, where the electrons are not. So that's the first version, the first definition of a dipole. It shows that a bond is a dipole because it's showing where the electrons are going. Our second definition of a dipole is just talking about a molecule. All it's saying is this molecule polar or not? N2. We just said, not a polar bond, they're both sharing electrons equally, so this molecule is not a dipole. We would say the whole molecule is not a dipole. HCl, we just talked about it, we said this is a polar molecule, and so we would say this molecule is a dipole. A polar molecule you can also just call a dipole. Okay? So definition number 2 is talking about the molecule and saying whether or not it is polar or non-polar dipole. Now this third one gets a little bit more confusing. You're talking about the overall polar charge and direction of a molecule. If you look at water, and we'll look at water here, we know that water is H2O. It forms this Lewis structure with 2 lone pairs on oxygen, and it has this kind of bent shape. Okay, we've learned all of those things. But now we're looking at polarity. So where are all the electrons in this molecule? Okay, between the bonds here, but they're also all on oxygen. So this oxygen has all the electrons in the molecule, and so it becomes partially negative. And hydrogen is getting the electrons kind of taken away from it because the oxygen has all the electrons, and so they become partially positive. So, when you see this, you're seeing that the oxygens are winning the battle, and the hydrogens are losing it. And what's cool about this is this makes water molecules kind of like a magnet, where you will have poles on each end. And this is why we saw that we could actually bend water the other day. So you're going to have poles on each end. The part with the hydrogens, the side with hydrogens, is going to be the positive pole, right? Like a magnet has the positive north pole, okay? And the oxygen is going to have all the electrons. It's going to be the negative south pole. And so the overall dipole of this molecule is positive towards the hydrogens and negative towards the oxygens. So this is talking about the overall dipole of the molecule, and how it is overall polar. So that's what you need to know about polarity. Again, when you watch this video, go ahead and go through that comic, read through it, watch this video, and check it all out as you go through it. Once you're done with that, you can answer the questions in the Smells Lesson 16 comic questions. I hope you all have a great day. Kristen, thank you very much for your help today, for being an insignificant weak penguin, even though you're not in real life. And I hope you all have a great day, a great weekend, and that's all I got. So have a great day. Let's get a 1, 2, 3. Clap on me. Thanks, guys.